In this paper, we have proposed a unified framework to simultaneously handle the tasks of 3D hand pose estimation and action recognition for an egocentric RGB video. Our core framework is a hierarchical temporal transformer that has two cascaded parts, where the first one refers to a relatively short time span to output per frame 3D hand pose and object label with enhanced robustness under occlusion and truncation. And the second one exploits the long-term temporal queue by aggregating the per-frame information for action recognition. In this way, we leverage different time spans according to the temporal granularity for pose and action, and model the correlation between the two tasks with different semantic levels. Extensive evaluations on two first-person hand action benchmarks verify our key designs and demonstrate the effectiveness of our method. Our motivation comes from the following aspects. Firstly, perception from individual frames shows severe ambiguity of action types, as well as frequent occlusions and truncations for hand pose. Therefore, in response, we leverage the temporal information for both hand pose estimation and action recognition. Secondly, we notice the different temporal granularity between hand pose and action. While the action is related to longer time spans lasting for several seconds, the hand pose depicts instantaneous motions. Moreover, we notice that the action has a higher semantic level, which is usually defined in the form of the verb and noun, where the verb can be derived from the hand motion, and the noun is the object being manipulated. Correspondingly, our framework is a hierarchical temporal transformer with two cascaded blocks, to cope with the different temporal granularity and semantic correlation between hand action. For the proposed hierarchical temporal transformer, the first block leverages the short-term temporal queue for hand pose estimation. This pose block takes a short sequence of per-frame ResNet features as input, and outputs the per-frame 3D hand pose and manipulated object label, by exploiting the temporal information shared among the input frames. To let the pose block focus on a narrower temporal receptive field, and avoid attending to the long-term temporal queue, the input video is divided into consecutive segments by a shifting window strategy. The divided segments are then processed by the pose block in parallel. The second block is the action block, which refers to the long-term temporal queue for action recognition. This action block has its temporal receptive field the same as the full input video. The input of the action block refers to the per-frame predicted hand pose, object label, and image feature in the full video, and the output corresponds to the action label performed in the video. In this way, the proposed hierarchical temporal transformer copes with the different temporal granularity and semantic correlation between the hand pose and action. The maximum available input length of the proposed HTT derives from the limitation of available computational resources. As a result, long videos are then divided into consecutive clips by adopting the shifting window strategy. In the testing stage, for the original video, its segmented clips are respectively fed into the proposed HTT. The per-frame hand pose is estimated by the pose block, and the action category is voted from the predictions among the segmented clips. Note that in this way we achieve efficient computation as each image is processed only once by both the pose and action block. Moreover, in the training stage, for data augmentation, we offset the starting frame to each of the first T frames, where T corresponds to the time span leveraged by the pose block. This ensures that both the pose block and action block consume different augmented data generated from the same sequence, and avoids feeding duplicated inputs to the pose block. We first evaluate on the FPHA dataset. This dataset records 6 subjects performing 45 actions, interacting with 26 rigid or non-rigid objects. 21 joints for only the subject's right hand are annotated. On this FPHA dataset, we demonstrate the effectiveness of our method with competitive results for both action recognition and hand pose estimation, where we outperform related baselines for both tasks. We then evaluate on the H2O dataset. This dataset has 4 subjects performing 36 actions related to manipulating 8 objects. Markerless 3D annotations for both hands with a total number of 42 joints are provided. On this dataset, we also outperform the related baselines for both tasks of action recognition and hand pose estimation. Moreover, our better performance on 3D hand pose estimation also demonstrates the importance and benefits of leveraging the temporal coherence for robust hand pose estimation under frequent occlusions in the egocentric view. We first verify our design of leveraging a short-term temporal cue for hand pose estimation, with the timespan t of the pose block as 16. We compare with two baselines. The first one is the image-based baseline, whose t of the pose block is 1. And the second one is to use a long-term temporal cue for hand pose, whose t of the pose block is 128. For visualization, we denote the ground truth hand pose in green and the estimated results in blue. Furthermore, for the settings using the temporal cue, we show the attention weights in the final layer of the pose block. We observe that, by referring to the short-term temporal cue for hand pose, compared with the image-based baseline, we show enhanced robustness under invisible joints. While compared with the baseline using a long-term temporal cue for hand pose, we avoid over-attending to distant frames and ensure sharp local motions. For action recognition, we leverage a long time span for the action block and examine our learned action block, where for the final layer of the action block, we visualize the attention weights from the action token to the frame tokens. Here the demo video corresponds to the action of Take Out Espresso, whose action can only be judged by the last few frames depicting the process of taking the capsule out of the box. We observe that these key frames for action recognition are given the most attention. Furthermore, we provide more cases in our supplementary video, where the distribution of attention weights shows clear correspondence patterns with respect to different actions. To conclude, we propose a unified framework for 3D hand pose estimation and action recognition from observed egocentric RGB videos. We leverage the temporal information for both pose and action, and build a hierarchical temporal transformer with two cascaded blocks, to cope with the different temporal granularity and semantic correlation between hand and action. Our proposed HTT shows state-of-the-art results on FPHA and H2O datasets.